Okay. Oh, you got the momentum one already, understood it. So that's a revision package, is it? Okay. Yeah, like probably better for you to do some of the MCQs as well. Maybe before the end of today, you just make sure you do a double check on all the equations and syllabus that you're tested on. Yeah. Are you aware of that? As in, have you done that? Yeah, and the data booklet, you done all that already. Oh, okay. That's awesome actually. Okay. I remember doing this earlier this year and I forgot how to do it. So I'm gonna have to try again. No. So the car, okay, I mean they said the car is a point object, so we treat it like a point object, okay? Right? So they said that the car is 15 meters away from the garage, right? The garage wall. Okay. So you basically just um so you're basically trying to push the car forwards, right? And you're trying to make sure that the car stops. So you're trying to push it, right? You're trying to push the car yourself. Okay. So you want to push it forwards. So when it goes forwards, when it accelerates, you can go at 2 meters per second, right? But then when it decelerates, because you need the car to stop here, you need to decelerate at 3 meters per second squared, right? So you can get it moving at 2 meters per second squared. You can get it to stop moving at in 3 meters per second squared, right? Then the total distance is like 50 meters, and they ask you what's the least time, right? What's the shortest time, right? To put the car back in the garage. So what's the least time to travel 50 meters, right? So with an acceleration of 2 and a deceleration of 3, what is the shortest amount of time that you can put the car back in the garage? I honestly forgot how to do this, because in my mind I'm just thinking what VT graph. So you can go up and then down like this, something like that, and then the area here should be like, you know, like 15, right? The area will be 15 meters per second. So and you're supposed to find the t here like this. Yeah, the t. Mm, if I can find out what's the like the top of the triangle here, right? Then you know, yeah, if I can find out what's the top of the triangle there, yeah. Is it possible to find the top of the triangle? Like what? What you mean? What you put this one as x? No, no, I just put it as t. You don't. Oh, at this point here, you put it as x, is it? So that means what? Wow. So we have wow. Okay. So we got like three unknowns, isn't it? Right? We got three unknowns. You got t, x, and v unknown. Okay. But we do know a couple of things. Um, 2 times x equals to v, right? And 3 times x equals to v also. Because from that speed, from this, oh no, 3 times x t minus x, sorry, yeah, 3 times t minus x equals to v. Sorry. Okay, basically the gradient here, right? The gradient here is 3, right? Because the gradient 2 and the gradient here is 3. So the gradient here will be what? V divided by x over t over x. So, sorry, v divided by t minus x is equals to 3. Yeah, something like that. So v is equals to 3t minus x. Correct? Yeah, so that's the first two equations. And then there's a last equation which will be half times v times t is equals to 15 meters. Am I right? Yeah. I mean, technically you can just can you solve? You got three equations. Can you solve for it? Like so from the first one, these two here, we can equate the both of them. What do we get? We get 2x equals to 3t minus 3x. Is that right? Yeah. And then can we put t x as subject? How about x as a subject? Should we put t as a subject, or x as a subject? I think we should put t as a subject. Hello, come sit down. So t as a subject is what? Is it 5 over 3x? 5 over 3x. Then what I want to do is I want to sub this into here. Am I going around a circle? I don't know. Half times v times 5 over 3x is equals to 15. Uh, can I simultaneous with this 2x equals to v thing? How about I sub in v into this one here? So v is 2x. I can find x already. Yeah, I can find x. Then I should be able to find t. Yeah, I think so lah. Yeah. I think there's no least time. I think it's more like there's only one solution because the area must be 15. There's no such thing as a like, because if you decide to move this line here closer to slow the car down, it's it's shorter than 15. If you decide to shift it further, then it's longer than 15. So there's only one solution where you get this one and this one, they intersect, and then the area is 15. So can you find v already? T is 5 seconds, is it? Just nice 5 seconds. Okay. I mean, whatever it is, we just need to find the time, right? So t is 5 seconds. Is that an answer? Yeah, just check answer. You got questions? No questions? Oh my god, then you come down. Then you want me to go through anything in particular? You can do the exam style though, because I'm really concerned about the MCQ. Your school MCQ is always a bit crazy. That's what I am quite annoyed by. So the exam style one. I mean, you have until like 5:10. I'll be available to you until 5:10. So yeah. But in any point you need help, I can go into a bit of revision. Is fine. Hmm? 5, huh? Yeah, there you go. So this one here. I don't know whether you saw. Yeah, this is that's your understanding. Did I solve it the last time around? Okay. I don't remember solving it myself. I think I may have told the students that don't worry about it, but I mean, in my mind, I'm now solving it. So I guess from time to time, it happens. I subconsciously figure out how to solve it and then come back again. Yeah. So the way to do this question is basically you're supposed to push the car, right? The car can move forwards at acceleration of 2 meters per second squared, right? But you have to stop the car because you don't want it to crash into the garage, right? But your best acceleration you can do is 3 meters per second squared. So they want the least time. So basically you just want 2 and 3, right? For the least time. And when you use 2 and 3, what happens is that it's a straight line here, right? 2 meters per second squared is the gradient, right? Velocity time graph, and it's 3 meters per second squared is the deceleration, right? The gradient, okay? In a velocity time graph. Basically there's only one answer. It's not like oh, there's a range of answers. There's only one answer because we want to get to the point whereby the area here is 15, right? So there must be a point whereby it intersect. So what we were doing just now is we went to establish that we don't know t, we don't know x, and we don't know that v that they cut it. Like we don't know how much speed is it there before they have to start slowing the car down, right? If not, you'll crash, right? So there's only one answer to this. So that means that if you have three unknowns, you have to come out with three equations, right? So we came out with three equations. Um, like we put x as the intermediate time, the time you need to start slowing it down. So we put it as the gradient of 2 times the base here, the time, that will be the v, right? And then this one here, the gradient here is v divided by this time, t minus x, right? And that's equals to 3, the gradient is equal to 3. Well, technically it's minus 3, but okay, it's fine. I think you can just use it as magnitude. So two equations here. And the third one will be the area of this triangle here is 15 meters. So 1, 2, 3, solve it simultaneously. Yeah, right. So three simultaneous equations. Yeah. Huh? Is it? My math is so bad. I can't see it. How do y'all see it? I don't understand. I don't see how y'all can see it's 2 plus 3. That means what? This, huh? What? What's 2 plus 3? Wait, why is it 2 plus 3? Huh? Wait, what? Or is it the lowest common multiple? Um, is that not it? Sorry, what? Huh? I don't see 2 plus 3. I don't get it. 2 plus 3 is what? Nah, what? Okay, never mind. It's fine. Yeah, anyway, yeah, as long as you get answer, it's fine. Like, yeah, I would do this method. What, can you explain a bit about the 2 plus 3 thing? How does it work? Oh, really? Okay, that's fine. Okay, I'll just leave it then. Yeah, you have another question, was it? Oh, but that's a momentum one, and you said that you're done with that. You understand that one already? Hang on, but do you know why? So impulse is basically what? What's that? Okay, so just change the momentum, right? Okay. What exam do you have this morning? You didn't have anything. What? Oh, Chinese. Okay. Aren't you like you wait, are you from, no, you're local. No. You're local. Okay, no, because like I mean it's like the name, right? Yeah. I always thought that it's very common in like China Chinese to have that Yanni and then they just change it to the English name or something like that. Oh, okay. That's a bit surprising. Um, okay lah. Then like that, then we have some order to it lah. Let's do this, okay? Wait what are you working on, Jace? What papers are you talking about? Have you not done the exam style? No, dude. Wait, hang on. Let me just show it to you then. This one. The exam style, right? In the main folder, and then you can just choose like one of them. Yeah, yeah. Are all the papers tomorrow or is it split? Oh, it's tomorrow. Okay. So you got the 1A, 1B MCQ as well as the kind of like experimental questions, right? Wait, You guys are you tested on circuits again? No circuits. Okay. The flying back and forth one? I did that day, right? You I thought I explained it to you before. Yeah, yeah, it's actually not that not that what call it? Not not very complicated question. They just make it sound complicated, but the idea is this. So they started off with the distance, right? Let's say, was it 50 km? 70 km. Then one of them was traveling this way at 30 km per hour, and the other one was traveling the other way at what? 20 km per hour, is it? Sorry, what? 25 and 10, is it? 25 and 10. 25 and 10, sorry. Yeah, so one is 25, one is going 10 like that, correct? 15 and 20, sorry, 15 and 20 km per hour. No, no, wait, hold on. So the fly, right? The fly is not like you don't have to care about the fly for the first part. The first part is basically when do they meet? When do the two cyclists meet, right? So like how long must the cyclist here be traveling and like for the same amount of time, how long must the other cyclists be traveling so that they cover the 70 km in total, right? So you have this hang on, so you have one that's going this way at 15 km per hour, and the other one is going at 20 km per hour, right? 20 km per hour, like this. And then the distance total between them is 70 km, right? So the question is, how long would it take to travel that 70 km? Yeah, so basically it's 2 hours. Yeah, basically it's 2 hours. So 2 hours later, this guy will be like, here, right, 30 km away, right? But then the other guy would have been here, 20 km away, right? 40 km away, sorry. And therefore they meet right here. They meet at this point here. That is, yeah. I mean that's where the fly will be also. Because the fly's motion doesn't is not affected by the cyclist's motion. So when the cyclists do meet each other, that's when the fly and the two of them meet all together at the same time. Yeah, correct. Yeah, yeah. So it's like that's why they put the fly there. It makes it complicated, but it's actually just ignore the fly. Yeah, it does, right? So it does bounce back and forth, right? But whatever the fly is doing, the cyclist just does what they need to do, right? So the question is, when do the cyclists meet? They meet 2 hours later here, right? But then the fly is just in between them. So by the time they get very, really, really close to each other, right, the fly is just bouncing back and forth, bouncing back and forth, bouncing back and forth, all the way until they meet each other. The fly is just right at the same point at the same time at the 2 hour mark at this position here. Yeah, stupid fly lah, but yeah. But then the question is, what's the average speed that the fly has what's the eh? What's the average distance? What's the total distance that the fly has traveled? So they said that the fly was traveling at a certain speed. What's the speed of the fly? What's the speed? Was that 30 km per hour? So the fly was traveling at 30 km per hour. Yeah, 30 km per hour. So the question is how far, how long, or rather, what's the total distance that the fly has traveled? Yeah, basically it's just 2 hours. The dumb thing is just 2 hours. Yeah, yeah. So it's like a overly complicated question, but it's actually just like that. Because if I explain, if you just did it like this without the stupid fly, you would know how to do this, what? Right? It's just that they go and add in the fly, then it makes you feel like, oh, the fly has a, we have to do some special APGP calculation or anything like that. No, no, it's not. Yeah. Okay. Let me put some order to it. So for your 1B, all right, you would do this one here. There's a file inside under the promos prep. There's a file inside Revision Village. You go into this one, yeah, paper 1B down here. Right, you go into this one, right? And then you pretty much go like towards the end part where there's all these kind of like data questions and all. This one here. Okay, so 1B is here, right? So can someone just like make note of it that 1B is there, because you need to get some 1B down. Sorry. Okay. No, 1B is in tools. Yeah, 1B is tools. Yeah. Okay. Cause the tools is the experimental graphs and uncertainties and all that. That's paper 1B. Right? Okay, good. No, that's not it. There's also another one. Down here, there is a folder called paper 1B prep. right? Down here, there is a folder here called paper 1B prep. So you go inside here and you can see all these are paper trees, right? So from these papers, you only do the section A, which is like kind of like this one here. If you look at the first section, right? These are all the paper 1Bs, right? All these experiments and they ask you calculate the percentage uncertainty and all that, right? So that's the second part for 1B there. There are others around, right? You see these two sets of papers here, right? These two sets of papers. Their paper trees. Section A is also all 1Bs. This one here, this paper tree is also the section A is also your 1B as well, right? So this one here, this hang on, as you can see, this again graph work here as well. So like I've given quite a lot of like 1B examples, right? Yeah, hopefully something similar comes out. Have you done the paper here this 2023 November? Okay, so you can go ahead and do that one now. Just take note of this, so you're doing A4, right? You're being tested on A4, right? Rigid body mechanics. Yeah, you are, right? Okay. So rigid body mechanics is an option in this paper here, right? So if you go into this paper, right, you scroll. I'm sorry, it's a bit messy, but yeah. Then you can see this one here, this question, A4, right? This is in the paper tree. You can find the A4 there as well, right? Practically your whole folder here, you can find something lah, right? This one, the year 5 promo prep, this one here, you can find something. You've been doing test understanding, which is good. And then I mean, for MCQ, if you have time, you just go and hit the NCEX exam style lah, right? But if you want to hit the promo prep one now, can also. Like same thing for you also lah. Okay?